All right, hello everyone. This is Mr. Chris. I'm going to go over our homework. Problem number 12 here. I've graphed this, which is half of a circle, and I've cut it from y equals 0 to x is equal to 0. That's just the first quadrant. And then I revolved it around this y-axis. So the original picture was here, and then it got revolved over this way. And if I want to cut circles, I have to draw my rectangles this way because that's the direction the circles are going. This rectangle always follows this rotation. So I'm following the rotation. There we have it. And my circles are going to be complete solid shapes. So this is an example of the disk method. And since I have disk, I can go pi r squared. But look what I did here. I changed this from equation based on x to an equation based on y, so I can put dy. Now this came out perfectly the same. It doesn't always come out perfectly the same. It just depends on where the algebra leads you. And now I have 0 to 4 because my disks are spaced this way. So my circles go from 0 to 4. They're not this way, so I'm not looking at the x-axis. I'm looking at the y-axis. 0 to 4 pi r squared because every cross-section is a circle, pi r squared. Do the disk method, 128 pi. Number 20. Also, here's a line, y equals 4. There's the x equals -2 and +2. And I have this parabola, and I have that shape, and I revolve it around this line now. So it's a little different right there. I'm revolving it around that line. Now what happens here is there's my rectangle, and every line I draw this way is another circle. So this is again the disk method. Even though it looks complicated, it's just disk. Every disk on here is a solid circle. So my formula is pi r squared, and there's all the parts. You have all the parts here. I'm going to draw them again. This is pi radius squared. That's all you have. However, be careful, you always have to do top minus bottom. The top of this rectangle is the parabola, the bottom is a line, so it's top minus bottom. We did not do that up here because the top or the right was a parabola, but the bottom or the left was just 0. So there could be a -0 in here, but you always have to account for top minus bottom on there. So there we have it. That shrinks that down here, and now I can do this. Now notice what I did. A lot of people took this from -2 to 2. I know that parabolas are symmetrical, so I just went from 0 to 2 and times it by 2. Instead of doing both halves, I just did this half times 2, which is perfectly fine. Makes the computation a lot easier because I'm dealing with a 0 instead of a -2 right there. I just doubled that area. All right, number 34. First line, second line graphed over the domain 0 to 3. And we go ahead and draw it like this, and it rotates. Now here's my rectangle, top minus bottom. But be careful, every time you cut this, you have a washer. You have an inside and outside. This is hollow on the inside. There is no hollow area on this one. There is no hollow area on this one. This one is hollow. So I have to do pi big R squared. Let me write it here in red. Pi big R squared minus pi little r squared. That's the difference. So that accounts for top minus bottom, but they're circles. Top circle, bottom circle, if you want to think of it that way. Pi r squared, pi r squared. Do the computation, simplify as you go, and you get down there. On number 46, it's this graph in the first quadrant. You'll get a lot of these which just say the first quadrant, which is right there. Revolve it, and it looks exactly like this shape, just tilted on its side. It is pi r squared dx, 0 to pi over 4. This one, it says in the book, use a calculator. The integration here is very difficult because of this. Very extremely difficult. So just plug in your calculator. 1.21234. AP requires 3 decimals, so I'd go out 3 places. 44. We have this function here, which is this curve, this line here, and we're integrating from 0 to 8. However, we have a problem. If you do this correctly, what you'll notice is you have 2 shapes that are intersected. However, on this shape on the left, the line is on top and the root is the bottom. Over here it's the exact reverse. But this point in the middle is where they switch. So I have to do two integrals. From 0 to 4, this top minus this bottom. 4 to 8, this top, this bottom. So it just flip-flops, and you just have to do two problems. Do them separately, add them together, you'll get there. I left the integration to you, but they're all polynomials, so it shouldn't be too bad. On number 80, we have this picture, line, parabola. Here's where it is, from negative 1 to 2, that area, but it's not being spun. It's not a revolution. What's happening is we're building squares, so everywhere along here, there's a square here, and a big square here, and a teeny tiny square here, and everywhere where I draw a line, there's a square, not a circle. So what do we do there? Well, what's the area of a square? Area of a square is the side times side, length times width, side squared. So I just use that formula, but again, top minus bottom squared. So here's the area of my square, side squared. Up here I have circles, whoops, pi r squared. That's the difference. This is built out of squares, this is built out of circles. So up here we use circle formulas, here we use square formula. How do you know? This one says it's revolved. If you revolve something, you go around, you make a circle. Here it does not say the word revolved, it says the word squares. So you build squares. And last one, 80B. It's the same picture, but you're building rectangles, and the rectangles have a height of 1. So same thing, top minus bottom, but what is the area of this rectangle? Well, rectangles are length times width. So this is length times width. And the length is the top minus bottom piece, again, from down here. And what is the width? Well, they tell you the width. That's the height of the rectangle. So that's 1. In geometry class, you probably learned that the volume is length times width times height. Here we see it as length times width times another width, but it's the same thing. Length, width, height, length, height, width, it's all the same. So again, you have three different shapes being formed here. Circular cross sections, square cross sections, rectangular cross sections. Just use the right formula and integrate. Pi r squared, s squared, length times width. All right, I hope this helps.